Hi, so my name is Michael Marshall. I'm a PhD student at the University of Sheffield, and I'm going to be talking to you today about structural topic modeling, or STM. So, an STM is an example of a probabilistic topic model. Topic models are a set of methods that fall within quantitative text analysis, and I've put this diagram on here to try and give an intuitive sense of what a topic model does. Some of the key concepts to get our head around are that topic models try to use the co-occurrence of words to find latent topics within a set of documents. And a set of documents is known as a corpus. A document is a latent construct within the text data, and it has a specific definition in this context. A topic is a probability distribution over a fixed vocabulary of words. So to take an example, we might consider a latent topic that represents statistics. In discussing statistics, we'll have certain words that have a high relative probability that they refer to that topic, such as regression, variance, mean, and median. By contrast, we'll have other topics that have their own probability distribution over words. The topic of elections, for instance, might have high probability words such as vote, electorate, or ballot. But as these word associations with a topic or a probability, they'll also vary. So for a hypothetical example, we might have a 5% probability that the word regression is used to discuss statistics, but only a 2% probability that the word mean is used to discuss statistics, and a 0.001% probability that the word electorate is used to discuss statistics. The words that we use to describe a given topic is referred to as topic content. On the other hand, documents can be a mix of topics and in different proportions. So if we have a document that describes using statistics in order to understand elections, we can use topic modeling to estimate the proportion of the document dedicated to discussing statistics, which might be, say, 25%, and the proportion discussing elections, which might be the remaining 75%. And these proportions are known as topic prevalence. What we want and what we get out of a topic model is that these two things should converge, so that we have an estimate of the proportion of a document discussing a topic, and this is calculated using the probabilities that individual words in the document are associated with that topic. So topic models, like I said, are a category within quantitative text analysis, and I'm going to be focusing today on a particular one called STM. So the benefit of an STM is that it allows us to associate a covariate of theoretical interest to the topics. A covariate is metadata about a document, so not the words within it, but something like the author of the document or when it was created. And these covariates can be used to influence topic prevalence and content. And this tends to open up new research questions to us, as well as improving our estimates. It opens up new research questions because we can associate something of theoretical interest to how a topic is discussed and how frequently, and improves the estimations because we're including something that was key to the data generation process in establishing prior probability distributions. So it makes sense that Labour, for instance, would talk about certain topics more than the Tories and vice versa, and that they'll both, as parties, use different words to discuss key concepts such as the economy. And then an STM tries to account for these differences in the estimation process. This is a diagram that provides a heuristic representation of how an STM works. What it does is it'll go through each word in a document and assume the following generative process. One, that there's a prior distribution of the topic proportion in a document, which is estimated using a logistic normal generalized linear model based on a set of covariates referred to as X. And that's here on the left of the diagram. And then on the right, we have a prior probability that a word is associated with a topic, which is free to vary according to pre-specified covariates referred to as Y. Based on these priors and the similarity of documents in terms of covariates and co-occurrence of words, it'll go through each word in a document and estimate A, the topic the word is assigned to given the topic distribution in the document, and B, the probability of the word within the topic. The STM will iterate between these two probability distributions, adjusting them until they converge, so that our distribution of topics in documents converges with the distribution of words in topics. And when formalized, we can represent this process graphically, as we've done here, where we can see that the arrows coming together at W represent these probability distributions converging after iterating through each observed word. In that process, the STM will find groups of tightly co-occurring words that we take as representative of topics. So there can be quite a lot to take in with STM. It can be a bit unintuitive at first or a bit daunting. So we've got a motivating example to help communicate it, which is based upon a project that I was involved with, where we used STM to compare the political styles of Jeremy Corbyn and Ed Miliband as Labour leaders. Conceptually here, we can conceive of political style as a political performance in order to navigate political life, which incorporates what people talk about, but also things such as intonation and body language. But we're going into a particular component of that, what people talk about, in significant depth. We're approximating political style with what people talk about and the words they use to talk about them. For this, I had a corpus of text documents, which were transcripts of parliamentary debates, each taken from their respective times as party leaders. And this results in a corpus of 2,637 documents. And I use who is speaking as a covariate to determine the prevalence of a topic. Note that there is no content covariant here. Models were built with content covariates, but this didn't really substantively improve the performance of the model in terms of identifying topics. Topic prevalence ended up being the only parameter that really varied meaningfully between leaders, so the content covariate was dropped. So, assuming you've cleaned your data, the first thing you'll have to think about in the topic model is the number of topics. In STM, there are a number of topics, K, which are pre-specified by the researcher. You have to run an STM and tell it, I want 10 topics, but it's then up to the researcher to determine whether this produces a sensible output. In this vein, it's important to remember that there's no correct number of topics, but there are certain things you can do to make an informed choice. One of which is to run through a range of different numbers for K and then produce goodness of fit statistics for each. Here I've plotted 15 different models ranging from 5 to 20 topics against 2 fitness measures, semantic coherence and exclusivity. Semantic coherence is a measure that's maximized when the most probable words in a topic co-occur together very frequently, and there's a measure called FREX, which is the weighted harmonic mean between the exclusivity of a word to a topic and the frequency within which it appears in that topic. What we want is to choose a topic in the top right-hand corner of the plot, although here we have a negative relationship between the measures, and so there's no clear winner. And what I did, and what I would always recommend, is produce a few models and extract the highest probability documents for each topic and read them. Reading the documents is basically the best method of validating your topic model, probably bar none. And for this search for topics, for instance, the best performing model against these measures was a 5 topic model. But when reading the documents, it was clear that their topic assignment was producing topics that were just far too broad to be substantively meaningful. So instead, what I ended up with was a 13 topic model, which I presented in this table here. So here what I have is the topic number, the words associated with that topic, and according to 2 criteria, and my interpretation of what that topic therefore is. In interpreting topics, you can extract the words associated with it. You can do this via the raw output of the model, which is the highest probability words within each topic, which I've got here. But I've also put the words associated with the highest FREX score. And there are other measures, including one called LIF, which will return high probability words weighted to give preference to words that don't appear very frequently in other topics. Reading some of the documents, as I said, is always a necessary step in validating the model. You don't necessarily read them all, but you should extract the documents associated with a topic in terms of their prevalence and read those to choose between models and interpret topics. Following this process, I came up with the interpretations in the right-hand column here. Just to have a look at a few, we have topics such as pay and living standards, which is denoted by words such as wage, rent, work, and employ, and topics on the EU withdrawal treaty, which is associated with words such as deal, backstop, and customs. And one thing that distinguishes STM from other topic models is that the topics can be correlated with one another. So in addition to a topic on EU withdrawal treaty, we have a topic on the European Union more broadly, and this is associated with words such as border, market, and negotiation. And as you'll remember, this model included a covariate by leader to vary the prevalence of topics. And what an STM allows us to do, as I've represented here, is to actually estimate the effect size of the leader speaking on the frequency with which a topic is discussed. One of the things that stands out from here is that some of the differences in frequency are probably just reflecting shifts in the issues and the political agenda that were being discussed at the time. But there are some that are probably less affected by these temporal dynamics that we can use to understand political style. So for Corbyn, for instance, he's talking quite frequently about issues that might be associated with the Labour left, such as the NHS, poverty and benefits, and pay and living standards. Whereas for Miliband, we see more discussion of growth in the economy, and as well as a tendency to pose questions to the government and to discuss policy and parties. So taken together, some of these effects suggest that for Ed Miliband, there was some continuation of some of the rhetorical trends that we saw under New Labour, with a preoccupation with valence issues such as growth, and that he might be seen as someone concerned with winning the debate in the chamber in terms of who he's actually directly interacting with. By contrast, Corbyn might be seen as less concerned with winning the debate in a one-on-one sense, instead looking to appeal to core left-wing issues around inequality in the welfare state and perhaps trying to shift the conversation. One thing to be mindful of, though, with topic modelling is that it can sometimes be easy to slip into reading the tea leaves, that is, seeing what you want to see in the results. So it's key to read the documents highly associated with the topic and to contextualise these modelling results with interpretive judgment, qualitative assessment, and theory. And in fact, running an STM can really help inform our assessment of political style by framing our reading of individual debates. So for Miliband, the modelling suggested he was someone who discussed valence issues more, who tried to win the debate in the chamber, and who discussed policy more than Corbyn. And we've got some debates here that illustrate those themes. For the first document, Miliband is talking about growth and the economy, and he's holding the government to account for repeated falls in growth. For the second document, he's talking about the NHS, but not in an emotive sense. Instead, it's about policy. It's a bad policy here because nurses have got no confidence in it, and it's a broken promise as the government promised no top-down reorganisations. And what stands out to me from these debates is not that there's no moral content. He's talking about fairness, for instance, in the second debate, but rhetorically it feels like he's talking directly to people in the chamber. There are appeals here on the grounds of competency in relation to a valence issue, or there's a sense that he's trying to trip the PM up by getting something to stick to him personally, like the breaking of a promise. This is in contrast to Corbyn, who is talking on familiar ground of the left in terms of what he discusses, but we also often see him associate these topics with abstract concepts such as social justice or structural inequality that appeal to the left. So we have discussion in the first of one of Corbyn's pet topics on pay and living standards, where he discusses a fair economy. And then in the second, he's talking about poverty and benefits and mentions the injustices of our society. We get a sense here that Corbyn still talks about policy, but rhetorically, he's performing not just for the person in front of him in the chamber, but to a wider audience that might be characterised as his supporters. He frames policies here in a way that presents them as emotive, moral issues, and in language his supporters would recognise. And although he probably still sees the government as incompetent, it's not technical incompetence, it's incompetence in creating these systemic moral issues. So taking all these things together, we can see how STM and text analysis can help us understand political performance and political style. We see Corbyn talking about pay, benefits in the NHS, and he does so by appealing to abstract moral concepts with an emotive core. Yet where Miliband discusses similar topics, it's as an issue of growth and economic performance, and he tends to get into policy without necessarily attaching it to abstract notions of social justice. And so the final content slide I have is just a set of considerations to bear in mind when implementing an STM. Like I said before, there's no correct answer in topic modelling. We're looking to infer latent constructs through a more inductive process than we would in other quantitative methods. And so the results that we get can vary according to a number of choices, including how we initialize the algorithm, the covariates we choose, and the choice of threshold for convergence. The best thing to do is to produce a few models and to check the stability of the solution. Also, don't be afraid to change the parameters that I've just specified and check the results by reading a selection of documents. This is attested to by the fact that I started with a covariate that would vary the content of topics, for example, but reverted to just a prevalence covariate after inspecting the documents. Which is also probably related to the final takeaway, which is that an STM can often be most effective when used as a complement rather than a substitute to other forms of analysis. And this can include other forms of quantitative text analysis, but also qualitative analysis. Here, the STM gives us some broad information on how topic prevalence varies across the corpus, but some of its greatest value in understanding political style is in framing our reading of individual speeches. And one of the things that I haven't covered here in order to save time was that I also complemented the STM by running a sentiment analysis on each topic, which found that not only did Corbyn discuss certain topics such as pay and benefits and living standards more than Miliband, but he was also more negative in his sentiment in discussing those topics than Miliband, and that those sentiment differences were statistically significant. And that's it, other than some useful resources here in case you want to know more about STM in terms of some readings and some R packages.